Michael Soltis, and I am a professor in the Department of Computer Science, and I am also the chair of the Department of Computer Science, which has three programs under it: computer science itself, information technology, and mechatronics engineering. The three programs I mentioned are computer science, information technology, and mechatronics engineering. We also have two very popular minors. We have a minor in games development. I think that a lot of students are excited to join computer science precisely because of this minor. And we're lucky in that we have a new faculty, Professor Eric Kaltman, who is an expert in game development, and he is revamping it and improving it. We also have a minor in cybersecurity. This is another very popular minor, and a lot of the graduates of this program end up working for the Navy here in Ventura County. Mechatronics is a popular program. It's our engineering program on campus, and it is impacted, meaning that we can't unfortunately accept everybody because it's a small boutique kind of program, and we only allow 24 majors in mechatronic, freshman majors. Now, what is good for this program? It's in some sense, it's similar to computer science. Again, a background in mathematics, some propensity for coding, because you will be doing quite a bit of coding in mechatronics, especially of embedded systems. And again, a willingness to work. A lot of our students want to know what the difference is between computer science and IT. They're similar fields, but different approaches to a similar set of problems. Computer scientists have a little bit more of the science of computing in their program, and they're oriented toward programming. And they can therefore become coders, programmers, software engineers. They may maintain software, they may write software, they may design software, they may lead software teams. IT, on the other hand, is more concerned with the infrastructure. So how do you run IT operations? How do you set up a network? How do you have a backup system? So they build the IT infrastructure and maintain it. We are a very lucky major in that our students find work without difficulty. I would even say that most of our students have a job lined up before graduation. The reason is that there is such a big demand for people with this skill set. To give you just one example, cloud computing has been the #1 skill on LinkedIn in terms of skills wanted by employers since 2014. And cloud computing is the new paradigm of computing, and we introduce it into our curriculum through Amazon Web Services. So our students have no difficulty finding jobs. The question is for them to find a job that is most suitable for them. So some of them end up as software engineers. Some of them work in IT. Some of them end up working for the Navy. Some of them work for small business startups. Many of them end up with the big companies such as Google and Amazon and Microsoft. There's a lot of IT in the 101 technology corridor, and all these companies have quite an appetite for our graduates. So in the end, they have a choice, and often they end up working for a company where they did an internship. There is a misconception that you need to be super smart to do computer science or math or a STEM field for that matter. And again, smarts are good, but really the main thing from my perspective, from almost 30 years of experience, is to have good daily work habits. Do your work every day. Don't delay it. Practice. Do it every day. I would say also it is important not to be afraid to ask for help, whether approaching your instructor or a tutor. And the third thing I would say is that we have a lot of different opportunities to seek help on our campus. We have tutoring centers, we have labs, we have teaching assistants. They're there. If you want to learn and you do your part by working daily, then we will help you achieve success and graduate.